Hello everyone. Today I will present my data mining assignment 1. The first question that I will explain is random forest implementation. Let's start. These are the necessary libraries that I used, and this is the first class of my assignment. This is a node class. A node is like a box in our decision tree. Each node can ask a question or give an answer, as we know. If it's a decision node, it has a feature threshold and connections to left and right nodes, just here. If it's a leaf node, it has only a value, the final answer. This is the value. Let's continue with decision tree class. Decision tree class has a couple of functions. First is init function. Init function is like building a tree that makes decisions. The parameters control how the tree grows. Max depth controls how all the tree can grow. Min sample split is the minimum data points needed to split a node. And max features decides how many features to consider at each split. And the root is the starting point of our decision tree. At start of decision tree, it will be none. And the fit function, the fit method trains our tree. First, we decide how many features to use. If we say security, we use the square root of the total features. This is called feature bagging. Then we start growing the tree from the roots. Yes, continue with grow tree function. This method grows our tree recursively. The recursive means the function calls itself. We stop growing when we reach maximum depth. All samples belong to the same class, or we don't have enough samples to split. When we stop, we create a leaf node with the most common class label. Let's continue with best split function method. This method finds the best way to split our data. We try different features and different threshold values in here. For each combination, we calculate information gain. Information gain is calculated here for gain. Information gain tells us how good the split is. We choose the split with the highest gain. It's calculated here. And we return the best feature and best threshold values to the back. Information gain method measures how much better our split is. First, we calculate the parent's gene impurity. Then we split the data into left and right groups. We calculate gene for each group in here. Finally, we calculate the gain by comparing parent and children. Higher gain means better split. We return the gain. Find information gain method. It measures how mixed our data is, especially. All the necessary explanations is here. Find most common label method. It finds the most common class label. We use this to determine the prediction value for leaf nodes. Also, the explanations here. The predict methods. To make predictions, we use these methods for multiple samples. It calls traverse tree method for each sample and returns all predictions as an array. Traverse tree method walks through the tree to make a prediction. The algorithm is right down here. If leaf node returns its value, if decision node go left or right based on feature value, recursively traverse until reaching a leaf. And let's continue the create random forest model function. This function initialize random forest classifier with optimized parameters. The parameters and explanations is here. A random forest classifier from scratch. Uh, as always, we start the init function. Init function is starting all the parameters and features. And fit method training random forest uses bootstrap sampling. This is also called bagging. For each tree, we randomly select samples with replacement. This means some samples may repeat. We train decision trees on this sample and then add the tree to our forest. This also creates diversity, and each tree sees different data, so they make different mistakes. The predict function, we use majority voting. Three predictions here. Most common is get for majority voting. And load and prepare function. We load PIMA Indians diabetes dataset. This dataset contains health information about women's. Preprocessed data has two steps. First, we handle missing values, and second is standardization. We scale all features to have mean equals 0 and standard deviation equals 1 here. And then manual key fault cross validation. In this method, we divide our data into key equal parts called false. We use k minus 1 false for training and 1 fault for testing. Here. It prevents overfitting because the model is tested on data it hasn't seen during training. And the results are printed to terminal. And then these are manual metric calculations, accuracy, precision, recall, confusion metrics calculations. And display results function is here, method is here. And main execution is handled in this main function. Let's start again and see the results. We see the results, the dataset information, data preprocessing. Yes, we see the how many zeros that feature have, and missing value imputation completed. Yes, we see the accuracy, precision, and recall results for each fault. And also our total samples is 768, but per fault 153. Yes. It takes a little bit more time that I estimate. Yes, the training final model in complete data sets Let's continue. Our cross-validation results is here. And then final model accuracy on training data is here. Then we can continue with the second parts that I will explain. The second part includes local outlier factor class implementation. Uh, this implementation includes an algorithm works in several steps. This algorithm calculates distance between all points and finds k nearest neighbors, and then calculates reachability distances and calculates local reachability density, calculates LOV scores by comparing each point's LRD with its neighbor's LRD, and then points with high LOV scores are outliers. Uh, our first class is local outlier factor class. It measures the local deviation of density at a given point with respect to its neighbors. An init function in method includes the parameters that we must determine when starting this class objects. A fit predict function, it includes this is the main method that does all the work. It follows 6 steps. Step 1 calculates the distances between all points here, then finds key neighbors using distances, and then calculates reachability distances that I mentioned at starting, and then calculate LRD, and then calculate LOV using LRD and neighbors indices, and then the threshold and classify points as normal or outliers. Points with LOV scores above the threshold are outliers labeled as -1, and points below are normal labeled as 1. Calculate distances, find key neighbors, calculate reachable distances, and calculate LRD, calculate LOV methods are implemented here, helper methods. And the data loading part is here. We are loading the data using this method, this function. Yes, the visualization part includes one method. Plot results method includes several parameters. It visualizes animal detection results using scatter plot and some other stuff. And then we are plotting the LOV distribution using histogram of LOV scores, and then it is the main function, main execution function of LOV implementation. And we are also trying to compare the scikit-learn's LOV function with our implementation of LOV, our custom implementation of LOV function, LOV implementation, and then comparing the results here, and then visualization here, and then we are writing the top anomalies to the terminal, and analysis complete. Let's run again and let's see the results. Yes, forms 2D txt is successfully loaded, and I got the thousands of the samples. There are more than more than hundreds of thousands samples, and it's hard to detect for my computer, and it gave me the error. Then I selected the 1000 samples, and then results summary is anomalies detected 100, inliers detected 900, threshold here, max LOF score here, and then our graphs are plotted just like this. And distribution of LOF scores is this. Top 10 anomalies is here also. Thank you for listening. See you later.